Continuing our look at sequences, now we're going to talk about how to write an explicit rule, especially when you are given two different terms in the sequence, not necessarily terms that are right next to each other. So here I'm describing the process, whether it's an arithmetic or a geometric sequence. The first thing you want to do is set up the explicit formula two different times, because they're going to give you two different terms in the sequence. So write an explicit formula for each of the two terms they give you so that you have two different formulas. Then, if it's an arithmetic sequence, you can cancel the a sub 1 values by subtracting one formula from the other. This is like the elimination strategy. If it's a geometric sequence, then you're going to divide one formula by the other. Either way, this process should cancel out the a sub 1s. So if you have any a sub 1s left, look back at your work, see if you set something up incorrectly with the formulas. Next, you should either have a d or an r in the equation based on if it's an arithmetic or a geometric sequence. So just solve for that variable by using opposite operations, whichever one you have. And then the last step is you may be asked to find some other missing terms. So you might want to use the explicit formula to continue to compute any other terms in the sequence that they ask you for. So remember that the formula for an arithmetic sequence is that a sub n is equal to a sub 1 plus d times n minus 1. Well, they've given us some information here. For one of the setups, they told me that the second term in the sequence is negative 1. So the second term in the sequence is negative 1. Well, that means a sub n is negative 1. I don't know a sub 1 and I don't know d. But if it's the second term in the sequence, that means n is 2. So I can plug in 2 minus 1, which is 1. For my second setup, I was given the seventh term, and that number is 24. So now a sub n is equal to 24. I still don't know the first term in the sequence. I still don't know what d is. But they said that this is the seventh term in the sequence, so that means n is 7. So now if I plug in n is 7 and subtract 1, I get 6. So these numbers here are my n values. These numbers over here are my a sub n values. Remember how easy it is to confuse n with a sub n. So make sure you understand what the term is and which term in the pattern it is that you're looking at. That's the difference between n and a sub n. So what I have here are two different formulas. And you'll notice that if I subtract one line from the other, it really doesn't matter which way I go. I can do the red one minus the purple one, or the purple one minus the red one. Either way, what's going to happen is the a sub 1 terms will be eliminated. So for this setup, I'm going to subtract everything in this bottom equation. So you might want to put parentheses or something to make sure that you are remembering to change the signs on all of it. So if I have negative 1 and I subtract 24 more, that would be negative 25. And then, like I said, a sub 1 minus a sub 1 will cancel out, so that part's just gone. I don't need to worry about it. And then I have 1d minus 6d. I didn't write it as 6d, but d times 6 means the same thing as 6d. So since these are like terms, they can be combined as well. And 1d minus 6d is negative 5d. And to finish solving this equation for d, I can just divide both sides by negative 5, which gives me d equals 5. Well, now that I know what d is, that means we've just determined what the pattern is. So for my sequence, if I was to write this out, I had a blank space, and then I knew the second term was negative 1, and then I had a blank for the third, blank for the fourth, blank for the fifth, blank for the sixth, but then I knew that the seventh term was 24. That was the information they gave me as the sequence written out. They had filled in these two terms for me. Well, now that I know that d is 5, that means the pattern is adding 5 to go from one term to the next. So I could pretty easily just go through and add 5 to go this way. So negative 1 plus 5 is 4. Or I could subtract 5 to go backwards. This number would be negative 6. And I could fill in all these other numbers doing the same thing. Add 5, so that would be 9. Add 5, that would be 14. Add 5, that would be 19. So now I have all the terms in the sequence. Now they specifically just wanted to know the first term in the sequence, which I listed here. A sub 1 is equal to negative 6. But we also need to find the explicit rule. They could have asked me for like the 50th term, and I don't want to sit there and keep adding 5 over and over and over again. So for writing the explicit rule, remember that we use this original formula, but we only plug in a sub 1 and d. So what I'm going to do is go back to the original formula and write that a sub n equals, we just found that a sub 1 is negative 6, plus, we know d is 5, and then this is n minus 1. Now that's an acceptable way to leave your answer. If it's multiple choice, make sure you recognize that that's one acceptable way of writing the formula. Some books will make you go through the process of distributing 5 times n and 5 times negative 1, in which case I would instead write 5n minus 5, because here I have two like terms. I can combine the negative 6 and the negative 5 to write this as 5n minus 11 instead. So that's another acceptable way to write your explicit rule. Either one would be fine. If it's multiple choice, though, you'll just have to recognize that those two things mean the same. It's the same explicit rule, just written in a different format. And this would be the better thing to use if they asked me to go on to find something like the 50th term, because then I can just plug in 50 and compute that answer. Now let's do the same thing for a geometric sequence. First, let's write out the explicit rule for a geometric sequence. It's a sub n equals a sub 1 times r to the n minus 1 power. And what I know right now is the third and the sixth term. So if I wanted to kind of imagine my sequence, I don't know the first and the second, but I know the third term is 6. I don't know the fourth. I don't know the fifth, but I know the sixth is 162. So what I'm going to do is use the statements they gave me. The third term is 6, and I'm going to plug that information into this equation. So 6 is a sub n. I don't know a sub 1, I don't know r, but since n is 3 for this term, the third term is 6. If I plug in n is 3 up here, 3 minus 1 is the second power. For my second form of the equation, I'm actually going to write this one just above because it is usually easier to do the bigger term and the bigger number on top and then the smaller number on the bottom for doing your division or your multiplication. Technically it can be done either way, but I find that this way is usually easier. So I'm going to do the bigger number on top. So this is 162. And again, I don't know a sub 1 yet. I don't know r. But that was the sixth term of the pattern. The sixth term was 162. So if n is 6, when I plug that in, 6 minus 1 is 5. So here I have my two statements. And like I said, try to just use the bigger term, the bigger number in the sequence on top. And then that way when you're setting up your division for the geometric sequence, or if you're setting up your subtraction, this will be a little bit easier to compute. So now I just need to figure out 162 divided by 6, and that's going to be 27. A sub 1 divided by a sub 1, that's what this line is indicating for me, it's division. So a sub 1 divided by a sub 1 cancels, because if you have like 5 divided by 5, the numbers cancel out. But I have r to the fifth divided by r squared. So remember that when you are dividing variables, you just subtract the exponents. So r to the fifth divided by r squared is r cubed. And then this is an equation that I can continue to solve by taking the third root or the 1/3 power, whichever way you want to look at it. It's the same thing. So what to the third power equals 27? Or if you're doing your factor tree breakdown, the idea here is that I'm finding numbers that multiply together to equal 27. And since this index is a 3, that means I'm looking for 3 of a kind to bring a number outside of the radical. And this one worked out perfectly. There were 3 3s and nothing else. So I have my 3 of a kind, which means that my r value is 3. So I took the third root of both sides, I solved for r basically, and I got r equals 3. Well, now I know that this means I am multiplying by 3 to go from term to term. So if I want to go to the right, multiply by 3. If I want to go to the left, divide by 3. So to go to the left, 6 divided by 3 is 2, and then 2 divided by 3 is 2/3. And that's why it's still good to make sure you understand how to work in both directions, because sometimes when you're going back to the first term in the pattern, for example, you may get some fractions in your answers. It doesn't necessarily look like that would happen from the original information, but dividing by 3 gave me a fraction for the first term. And then I could keep going this way. 6 times 3 is 18. And if I multiplied by 3 again, that would be 54. And this way I can nicely check my answer, because if I multiplied by 3 again, sure enough, that would equal 162. So we found the first term, we found the common ratio, we have r, we have a sub 1. The last thing they want is the explicit rule for this sequence. So remember, the idea for this is just to plug in some of the numbers into the explicit formula here. Not every number, just some of the numbers. We want to leave a sub n as is. We want to plug in a sub 1 though, so that's going to be 2/3. And we want to plug in the r value, which is 3, but you don't want to plug in n. So I'm going to leave that as to the n minus 1 power. So that would be an acceptable final answer. We don't really need to do any other simplifying on that one. You will have a few word problems in this section, so I just want to give you some general tips and ways to identify which variable equals which number. The first thing you should do is look for a number that describes the object today, or maybe they'll say something about in the beginning or at the first count of some number. Whatever the case is, if you see something that seems to be happening in the beginning, that would be your a sub 1 term. Next, you want to look for terms that would indicate whether you have an arithmetic or a geometric sequence. So see if they seem to indicate that it's growing at a certain rate. Maybe it's like a flat number increase every time. A lot of objects growing are usually arithmetic, or it might be, they may indicate some kind of an exponential growth, which would usually indicate that you're multiplying by a number over and over again. And then tied to that, very similar to it, look for what number is describing the growth. If they say something like doubling, that would be an indication that it's a geometric sequence and that r equals 2. So you want to try to figure out which type of sequence you have and what that rate of growth is, if it's adding a certain number every time or if it's multiplying a certain number every time. So here's an example, and I'm going to highlight some of the most important terms here. First, it says there is 1 goblet in the vault at the start. So that's the information I'm looking at to recognize that a sub 1 is equal to 1. Some other important values here are the fact that it's doubling. The fact that it's doubling is going to indicate 2 pieces of information to me. So doubling indicates that it's a geometric sequence and that r equals 2. Now the fact that I have an r in the equation means it has to be geometric because arithmetic doesn't have an r value in the equation. So I'm just going to write r equals 2, but that also means to me that this is a geometric sequence. The last piece of information I need to get out of this word problem is figuring out what n is. How many terms will there be in my sequence, or what is the a sub n? Because they're actually asking us how many will there be. So what is the specific term if n is a certain number? Well, to find n, I'm going to use the 45 seconds. So 45 seconds are going to pass total, and the doubling happens every 3 seconds. So right now I have 45 divided by 3. And this number is going to be important for figuring out n. But this number is how many times the goblets double. What you have to think about is that if I was writing out the terms in my sequence, it starts with 1. After it doubles once, it goes to having 2 goblets. And then when it doubles again, it goes to having 4 goblets. And then it doubles again. And this keeps happening. But what I want to point out is the number of times it doubled plus 1 is how many terms in the sequence I have. So it's this plus 1 equals my n number, because the number of times it doubled is going to be 1 less than how many numbers I actually have, since there was a starting value. Basically, it left off the starting value here. So that's why I'm adding an extra 1 to figure out what n is. So now that I have my a sub 1, my r, and my n, 16, I'm going to be able to write my formula as the 16th term in the pattern, if n is 16. It's going to equal a sub 1 times r to the n minus 1. So 16 minus 1 comes back to the 15th power. So now all I have to compute is 2 to the 15th power in a calculator. And I'm getting 32,768. And so again, the trickiest thing about this, it's the n value. What might help you is to write out just a couple of the terms of the sequence and to try and compute it from there so that you can count what should n be in comparison to how many times the goblet doubles, for example. A lot of times you do need to do a +1 or sometimes even a -1 based on how the sequence and the word problem are written. But that's basically it. So you just want to identify your key components based on the information given in the word problem, you just have to be able to tie the numbers to different values, whether it's a sub 1, r, or n. And then when you compute your formula, you should be able to do this the same way we've done everything else in this section.